Mr. D-Lap. Sure. No, I do not. Uh-huh. All right, questions here. Let's start here. First, we got to go finish a couple things, and I do have a review sheet for you. Max.
Will the stuff that we did on the part of the thing that wasn't in chapter 4, will that be on the quiz or no?
No.
Okay.
No. With the essentially number 70 used it, but not any direct questions like that. So page 457. All right, don't be shy. Any questions? Yes.
93.
93. Log base 4 of log base 3 of 81. Okay, definitely need to know something, how to do something like this. 93 log base 4 of log base 3 of 81. I can't be.
No. I think it's one.
That's it? Okay. All right, the directions just say evaluate. So evaluate, you're coming down to a constant, a fraction, whatever. So we got to figure this out. So start on the inside here. Log base 3 of 81. Basically says 3 to what power? 3 to what power equals 81? Okay, so you might have to go through the 3 squared, 3 cubed. 3 to the 4th power is 81. So this right here, this gets replaced with, so log base 3 of 81 equals 4. That just gets replaced with the number 4. So now this says the log base 4 of 4. So you read that, you got to say 4, which is this base, to what power equals 4? Well, that answer is 1. So this whole thing boils down to the number 1. Okay, so evaluate that. So you got to figure out the different logs, kind of go through there. So that's 1 for those. Same thing for all those others on 93 through 98. You're going to come down to a constant answer. Like 94 is the same. You just got to keep taking, so it simplifies. Eddie.
96.
96. Well, let's see. The answer is 2. Let's see how we get that. 96. Log 2 square root of 2 base. Log base 2 square root of 2 equals 8. So this says 2 square root of 2 is my base. To what power equals 8 on this case here. And so we got to be able to figure that out. Well, in this case here, all right, it's a couple different things are going on. And we can get it to the same base, or you realize or not, but 8 is 2 to the 3rd power. Okay, right here, 2 square root of 2. Square root of 2 is the 1/2 power. What happens, what do you do here? Now this is like x squared times x cubed is x to the 5th, because what do we do to the powers? We add them? Well, technically this is the same concept here, except my base is a 2. That's 2 to the 1st. What 2 to the 1st times 2 to the 1/2, what do I do to those powers? Add them. So that's 2 to the 3/2. Okay? 2 to the x power equals 2 cubed. Well, right here, that's going to be 3/2 x equals 3. And so you can say 3x over 2 equals 3, multiply both sides by 2. 3x equals 6, x equals 2. I would say that's the long way. You might just say, all right, let me try a number. Let me try square it. What happens if I square it? Okay, and you can do that. But this is the kind of the way you would manipulate it, okay, using our properties.
I mean, in the book it says log 2, base 2 over 2, square root of 2, 8. It doesn't say equal to 8.
I shouldn't say equals 8 either. That should just be an 8. But that's still, I did it thinking of, that's the same thing. No, it doesn't equal 8, because then we would have a whole different case. So 2 square root of 2 to the x power equals 8. So that would still hold for that. So that's kind of how you go through that one. You know, so and if you can get it to the same base, and then there's some different operations that are going to happen through that. Okay?
Is this the calculator part or not?
No calculator. Okay. You wouldn't want to. I mean, all you got to do is type that in your calculator and spits it out. That's no fun. Okay, so I understand that would not work for you. So this will be no calculator. All right. Other questions? Wendy? 98. Log square root of 3 of 27. So, all right, I want you to think what we just did. So we're going to do something similar to that. So this means square root of 3 to the x power equals 27, right? Can we get these to the same base? Well, what is 27? That is 3 to the third power. And square root of 3 is 3 to the 1/2. And then that's to the x power. Well, those two multiply. You get 3 to the 1/2 x equals 3 cubed. And so 1/2 x equals 3. Multiply both sides by 2, divide by 1/2, whatever works. That's how we get x equals 6. Okay, for that one. So we want to get them to the same base. Look at the powers, compare those. All right. Max, was that the one you had, or you
Yeah.
had something different?
That's what I was gonna ask about.
Okay, are we good? Anything else? All right, you're going to want to open up your books to page 111, and we're going to kind of go through a couple things together. And I'm going to do something here real quick here. Before we go to that. We're going to be dealing with e to a power in this case. How do you convert that to natural log form? What's that like when you have e to a power equals x? What does that look like in natural log form? Okay, just think about it for a second. Okay. Gabby, do you know? You got any ideas? You remember?
Is it ln3?
Equals.
E to the x?
Just equals x. Because there's your base. Your base is assumed right there in that case. So when we did this, okay, it always equals the exponent. Always equals the exponent. And so you got to think here, if I got natural log of 10 equals y, that means e to the y equals 10. Sometimes I think it's a lot easier to go that direction. If I'm giving you natural log of 10 equals y, e to the y equals 10. Does that make sense? So if I'm going the opposite way, so if I got e to the x plus 2 equals 3/4. What is that in natural log form? That's going to be the natural log of 3/4 equals x plus 2. Okay, so think about going the opposite directions. If you convert it, think, all right, is that the same e to the x equals 3? Just kind of go backwards and make sure it makes sense in your head for that. All right, we're going to do a couple of these together. So page 459, 111. Start with a equals p to the ERT. Doubling your money. Now they use above that, it says an x. If you're looking at those directions, it says use the model a equals a sub 0 e to the kt, or ln of a divided by a sub 0 equals kt. They're all going to come up in different forms. This is really the PERT. That's the same thing. Remember I said the PERT formula is the same as the exponential growth or exponential decay formula, just different letters. So it might be easier to start with that. Now it said doubling your money. How long would it take to double your money if you invested P dollars at the rate of 8% compounded continuously? Okay. So once it says compounded continuously, I'm using this. That is that form. Yes, and I'll have that on your quiz tomorrow, and I'll explain that. I'm going to put these over to the side for a second. It doesn't say how much money you started with, does it? It just says you're going to do what with it? You're going to double it. It makes no difference how much you start with. You are doubling it. So I just want you to think about this here for a second, really, before you write anything down. what's going to take, how long. So we're looking for time. What rate do they give us?
0.0.
0.08. All right, so if you start with $100, in the end we want how much? 200. If I start with $1,000, in the end, how much do I want? 2,000. So it makes no difference what you start with. If I start with $1, how much do I want in the end? $2. So here's what's going to happen. If you pick a number, let's just say I start with $5,000, e to the 0.08t, this is going to be 10,000. Regardless of what you start with, when I divide by 5,000, what am I going to get on that left-hand side? 2. So it doesn't matter what I start with. If it says double your money, then this is going to be 2. It's basically like starting with a 1 and you're going to end up with 2. So whether you want to pick a number to start with and double it, or just understand that, I can let my principal be 1, my A be 2. I get 2 equals e to the 0.08t. This is why I went over what we did earlier, right here. Okay, I had 3 equals e to the x. I write it in natural log form. Once you get to this point, you're stuck. You can't really do anything. Write it in natural log form. Write it in ln form because it's a base e. We can do that. All right, what is that in natural log form? Let's see if any of this is sinking in. Peyton?
Would it be ln to the second power equals 0.08?
Not ln to the second power, just ln of 2, natural log of 2, okay, equals 0.08t. Now you can solve that. You got a calculator. This is definitely calculator part. You can take the natural log of 2. What do we have to divide by? 0.08. 0.08. And while you're doing that, I need to get my calculator out. All right, so this little step's going to come up a bunch here with this. All right, so you take natural log of 2, which is just ln of 2, close my parentheses, you may not have that, divided by, whoops, I got a multiplication, divided by 0.08. Okay, 8.66. So t equals 8.66. In this case, it's years. So about every 8.66 years, if you get 0.08% compounded continuously, your money's going to double. Okay, for that. So you kind of got to know how to set that one up. Okay, you can pick any number you want. Now, Newton's law of cooling. Now, there is a really big example on page. It kind of starts on 455, but the example's on 456. I'm going to do it just slightly different. But we're going to use Newton's law of cooling to solve 117. I will give you this formula. Do not worry about that. You don't have to memorize that. So for this one here, what do we got? All right, thermometer is taken from a room. Anything that cools or anything that's heated, like you put it in an environment, it's either going to cool to that environment's temperature. You got a hot cup of coffee, you put it down, eventually it's going to be whatever. If it's 70 degrees in here, it'll be 70 degrees. Okay, the rate at which it changes, we can use this. If you watch any of those murder shows, they always say, well, how long is the body, did she die? Did they die? Well, they determine based upon the temperature of the body. Okay, so it's going to cool down to whatever the surrounding temperature is. So they can figure out. That usually plays a role. So for 117, a thermometer is taken from a room at 75 degrees to the outdoors where the temperature is 20 degrees Fahrenheit. The reading on the thermometer drops to 50 degrees after 1 minute. Okay, find the reading after 5 minutes, and then how long will it take to drop to 22 degrees? All right, when doing this here, T sub S is the surrounding temperature. That is the surrounding temperature. T sub O, or T sub 0, is the original temp. K is kind of the rate of, like, at which it is decreasing or increasing. We don't know what K is at this point. Our biggest thing right now is to find find K. We got to do that. All right. And now T is basically the temperature after whatever time you have. So what would, in this case here, what is T sub S? T sub S would be what? 75. That's the surrounding temperature. What is T sub 0? What is the original temperature? Okay, that is going to be, oh, hold on, I did that backwards. What should T sub S be? If you read that, 20. And what should be the original temperature? 75. $75. All right, now after 1 minute, then the temperature is now at 50 degrees, correct? I'm going to use that information to find K. So that is going to be, this T is going to be 50 degrees. T sub S, the surrounding temperature, is 20, plus the original temperature, which is 75, minus the surrounding, 20. E to the negative K times whatever that time frame is. In this case, it's 1 minute. So that just becomes E to the negative K. All right, a couple algebra mistakes you got to watch here. This becomes 50 equals 20, plus 75 minus 25 is 55, E to the negative K. What I want to do is I need to get E to the negative K by itself. Probably the biggest mistake we typically see is you want to add 20 plus 55 together and make that 75 E to the K. You cannot do that because the 55 is a coefficient of that. It's just, it would be like 20 plus 55x. Okay, you cannot add those together and make it 75x. Okay, you got to subtract 20. You got to subtract 20, and you get 30 equals 55 E to the negative K. Now to get E to the negative K by itself, what do we divide by? 55. If it comes out to be a nice value, like a terminating decimal, you can use that. But if it's something like this, okay, just keep it in fraction form. So I'm just going to keep that as 30 over 55 equals E to the negative K. All right, here's this case that comes up. This is where the logs play a huge role. Convert that to natural log. What does that look like as a natural log? So that is going to be the natural log, ln, of 30 divided by 55 equals negative K. And then all I got to do is divide by -1 to get my K. All right, for this, and I'll have pretty clear directions on the quiz. Round your K value to 6 decimal places. It's not going to, because if we want this to be accurate, you either keep it in its exact form, okay, you could keep it like that, or you could round to 6 decimal places. So ln of 30 divided by 55, that is a negative. When I divide it by -1, whoops, what did I do wrong? I get 0.606136. 0.606136. Okay, round to 6 decimal places. All right, for that one. So now we haven't even answered the question because they say find the reading on the thermometer after 5 minutes. So now you got this K value, so we can substitute that in. Okay, I just rewrote this so I had this. So now I want to find the temperature. So we want to find big T when the time is 5 minutes. And so I know everything else here, okay? And so it's just a calculator problem at this point. So temperature is going to equal, temperature is surrounding area, I believe that is 20, right? If I remember right. 20 plus 75 minus 20, which is 55. You can just write that. E to the negative 0.6060136 times 5. And so I get T equals 20 plus 55 e to the negative 0.606136 times 5. All right, just type that all in your calculator. Round it to the nearest, for this case, my book has an answer to the nearest 100. The nearest 100. And so I got 20 plus 55 e to the power negative 0.606136 times 5. And I got 22.66 degrees. 22.66 degrees. Okay, we agree with that? On there. All right, now let's take a look at that last part. Make sure we know how to do that one. It says, how long will it take, or where's it at? Just go to drop the part B, because the other two parts, you're just plugging in different numbers for T. All right, so this was part 1I there, and this will be part B. We want to know when the temperature will be 22 degrees, even. So how long will it take to read and drop to 22 degrees? So find the time, which is little t, when the temperature is 22. So that means this will be 22. Okay, we said the surrounding temperature is 20 plus. That's already at 22.66 degrees after 5 minutes. So we're really close. T sub 0, 75 minus 20. E to the negative kt. I'm not going to write that k value in until the end here. So I get 22 equals 20 plus 55 e to the negative kt. All right, take a second, look that over. What do I got to do? Okay. Ready? You know? Got to subtract 20. Do not do the 20 plus 55. Subtract 20. I get 2 equals 55 e to the negative kt. Now don't forget, k is still that negative 0.606136. I'm just avoiding writing it. Divide by 55. Divide by 55. And I get 2 over 55 equals e to the negative kt. All right, this is where this happens. Okay, this comes up. You're kind of like, all right, what do I do here? Can't really solve it. You can't take the t root. You can't take the k root. You can't do anything like that. This is where you convert to ln form. So convert to natural log form. Okay, convert to ln form, which means that natural log of 2 over 55 is equal to negative k times t. Well, we know what k is. So I'm going to make that ln of 2 over 55 equals negative 0.606136 times t. And then I'm going to divide by that. And then, what does my book have? My book has the answer to the nearest 1/10 of a degree. Nearest 1/10 of a degree. All right, see what you get. Alex, what'd you end up with?
5.5.
5.5, it's like 5.47, which, like I said, nearest 10th of a degree, would round up to 5.5 minutes. All right, anything that's going to increase temperature, you could use this for like, you put something in the oven's at 350 degrees, you put it in at 70, it's going to increase until it gets to 350. Okay, and we can figure out the rate the temperature's increasing or the rate the temperature's decreasing. But we gotta have like a reading to get the K value. Okay, so you gotta find that for this case. All right, now I'm not gonna go through this because I want to give you some class time. Okay, I'm gonna give you this review. The answers will be in the class notes. And let me hand this out. All right, one thing I just need to make you aware of, if you would just flip it over the back, and it's just with how this comes out, and sometimes I've been fine, but the bases look a little deceiving. Like on 6A, I think it's pretty clear it's log base 5 of 1. Okay, and this is log base 81. But for some reason, on other ones I have issues. If it's where a base should be, it is a base. This is base 6, log base 6. Okay, of log base 4 of 4. That just with the program, for whatever reason, I run into issues every now and then with the bases. And this is 5 to the log base 5 of 4. And this is log base 2 of log base 3 of 9. He said sometimes they come in perfectly fine, and then other times I can't figure it out. You might want to start with number 10 because that's the one we just did. Okay, that's a coffee cup with a temperature 101 degrees, placed in the freezer with a temperature of 0. Why anybody would do that, I don't know. After 8 minutes, the temperature is 54.6. Okay, so you might do that. Okay, and you do not need to turn this in. Okay, I will let you know that tonight at 9:30, if you have questions, I'll do a Canvas conference. Because I'm not giving you really an extra day to review, so if you go over this and you're a little bit stuck on some things or anything else, I'll do a Canvas conference tonight at 9:30. So I will put that up here. Okay. And Gabby, I don't know if you're asleep then, sorry.
Yeah.
You go to bed at 8:30.
Yeah.
Might be awful late for you. I can maybe record it. But for those of you watching at home, you could probably go back through here. Here's some of your answers. State the domain and range of vertical asymptote. Make sure you do that when you get to the front. And here's the answers to the back. Ooh, 43 degrees.
Keep it
I'll keep it right there. All right.
I don't know. So what, equations are you gonna give us?
Oh, the equations I will give you are what's at the top on the front.
Okay.
Yes. Everything there, it'll look the same for the calculator part. For the no calculator part, you don't need any of those. So the equations, for those of you who are watching at home, will be whatever's at the top of there's a compound interest formula, continuous compound interest, exponential growth and decay, and Newton's law of cooling. Newton's law of cooling. And I'll keep that up so you can see if you're doing it right. That's no problem. All right, do not turn this in, but this is just for the quiz. Work on it to the rest of the class, though. And I'm going to stop this.